today we're going to be talking about how every person on the planet, to an extent, sees the world very differently. So what I'm going to start with is perhaps a little bit hectic, but we'll see how it goes. So essentially, for the last 200 years, there was research done by Jean-Baptiste that basically stated that there was greenhouse gases that were building up and heating the planet, which is around about the same sort of time as the Industrial Revolution. So for the last 200 years, and certainly since the end of the 50s, we've kind of been running on a silent alarm into the bombardment of different colours. So the kind of planet that we live on right now is divided up into nations, and as you can see, there are multiple divisions, not just among countries and boundaries, but also geographically. Through cartography, we can either decide whether or not we're actually going to work together, or we're going to start being more nationalistic, which in the last few years we have started to experience. And as you can see here, everyone has a national identity, and that's quite important to them. So how is it that we can start thinking about the planet as a more together type entity? The problem is that we don't really exist in different countries all at once. We exist in our own space and time, and essentially it's quite difficult to have an idea of how someone's feeling on another side of the planet, even if we're very connected. On the left, you've got essentially the first ever photo that was taken of the Earth, which is by a lunar lander called Surveyor 3. And that kind of gives you a very grainy, blurry glimpse of a planet taken from another part of the cosmos. And then so on and so forth. In terms of technology, we are very much interlinked, but we're not necessarily connected as we might think sometimes. So this is going to be a bit of a crash course in cartography, and I do apologise, because I know a lot of people thought they'd finished geography when they were in school and left. So did I. But it's actually quite fascinating. The fact that on the left you've got, this is a representation of the method of the gnomon at the time, which was by a Greek, but that actual illustration was done in the 19th century. So that's all done by description. That's not actually exactly how it might have looked, just based on writings, etc. The next map is quite also fascinating. I'm going to be saying that a lot, so I apologise as well. So this essentially shows Europe, Africa, all of the sort of the main continents, and before we've even had a chance to know what the rest of the world looks like, we thought that this was it. This was our kind of home, and this was how connected we were, where the sea was all around us, and the land kind of basically was a horseshoe for trade and ports. And for a long time, trade has been sort of the sole pushing force of actually of map generation. And the one on the right is something that for a long time, since it was first drawn up, was actually just left in a book for a very long time, and then through an auction in the last 3 years, David Rumsey, who is an entrepreneur in some respects, but also has a map collection which is now at Stanford University Library. They digitized and put it all together, and essentially this was showing a kind of whole world view. Again, this is pre-Renaissance, pre-discovering the Americas. And then we get on to the famous, nearly get on to Mercator. This is actually, on the left, an idea of what the world would look like based on travel and trade. And so the world is starting to build up and starting to actually gather some speed in terms of industrial ingenuity. The comparison here is that the strange thing is that our world view, the more it expands, the more we feel we are getting smaller and smaller. So we like to control things. And it's just within our human nature that we have to control certain things that we feel we have some aptitude with. So on the right we have this very strange looking time zone map where you would imagine all the lines would be going straight, and in fact all the countries have their own sort of idea of what time is, which is great if you're someone whose punctuality isn't good, but it's also not great if your punctuality isn't good. So we'll leave that there. And so we get on to the infamous or famous Mercator projection. And as it's sort of progressed over the last 100 or so years, it has become more and more politicized, and in fact, countries such as in the northern hemisphere, as you can see, quite like showing this map to all their fellow nations because it makes them look more important. It makes America look as the US look as big as Africa, which is unfortunately for them not true. So there has been suggestions of actually in education having sort of moving away from the Mercator, which originally was meant to just be for trade across the Atlantic and then the Pacific. And it just gave sailors a very nice way of knowing what was in Europe and other trade ports in the north and south parts over to the Americas and back. So on the right is a slightly more proportionally fairer to the more southern parts of the southern hemisphere of the Earth, and actually represents dimensionally the size of the country rather than based on its wealth and pomposity. And now we come to the last few years. Other maps have now been started to shared mainly across the internet. That the one on the left actually expresses this idea that there is not 7 seas or several oceans. There is actually one big ocean that is interconnected, and it just so happens that all our land that we so like to name and hold dear is actually kind of just getting in the way of the natural currents. But at the same time, the Earth is a multiplicity of different systems, which is where the one on the right is quite fascinating because it proportionally gives an idea of the entire planet in terms of the constants and landmass, as well as politically not being too damaging to each other. It's a sort of a slightly fairer and more equal, socially equal map, and also for once doesn't show that Antarctica is just this strange bumpy mass along the bottom of the southern hemisphere. So we move away from cartography, and now we come to human exploration. And the last photograph that was taken of the Earth by a human being on Apollo 17 by one of the crew members, is still contested who exactly it was, is the first time that captured on camera or in any form or medium a full disk of the Earth, almost full disk. You can see the terminator on the right, which denotes the night that's oncoming across Africa. And then on the right is kind of where we are now, without human exploration going beyond the lower Earth orbit, or the LEO as it's called. You essentially get what is known as a satellite image, and that image itself is taken from about 1 million miles away, and at Lagrange point 1, which is kind of quite far away anyway, so the camera's essentially zoomed in to an extent. And then we'll move on to an animation which was the moon kind of moving in between, getting in the way, sort of blocking in the sense, and the Discover epic camera that NASA put up in space has captured a kind of context within the wider solar system and our cosmos, and making us perhaps feel a little less alone because we know that the moon is actually kind of, in partnership in some respects. And in terms of space exploration, we are kind of coming to a bit of a strange fork in the road. We have, on the left, we have the International Space Station. Cameras are put outside of it and recorded over a 92-minute cycle. And on the right, we have a very fashionable idea by Elon Musk about putting one of his cars up in space, including a spacesuit that he hopes to send to Mars one day. But the difference is that on the left we have a public idea, so even though NASA is essentially funded by government money, but it's still seen as a global voice for exploration and human endeavour. Whereas on the right, there is a certain amount of that, and they are in collaboration with each other, but there is a danger that we start building and creating borders in empty spaces that for a long time have just been nothing but voids. So I'm just going to pass the clicker on to my dad, and thank you.
So I'd like to talk to you about what are the vital signs of the state of our planet. For 30 odd years now we've been using satellite data to extract truth, evidence, information about what really is happening in the atmosphere and on the surface. This shows a couple of examples, one of which relates to the famous carbon dioxide. Unfortunately we can't see it, unlike other forms of pollution. But we can certainly measure it, and we've been measuring it since 1957 in an area in Hawaii, which had the first records, which corrected all of the bad information, fake news that had been around previously. And of course, most of these emissions from the last Intergovernmental Panel on Climate Change in 2013, with the next report due next year, indicate that human beings are still responsible. Now, we can also look at how much carbon dioxide is being absorbed by the ocean, which fortunately is able and has the capacity to absorb a great deal, but in the process, of course, is killing coral reefs around the Pacific in particular, and this shows a representation, whereas on the right is an example of how humans together can actually decide that we're going to stop something and stop the dangerous pollution that was causing the destruction of the ozone layer and increase the amount of ozone within the boundary layer within our cities. So we can now use these kind of instruments that we have in space. The European Space Agency is the only space agency in the world at the moment that has a series of up to 10 satellites measuring different aspects of the world's climate. Shown on the left is the nitrogen dioxide, which is produced by coal burning and also a byproduct of diesel combustion, and on the right-hand side was carbon monoxide. So we can look at the atmospheric constituents. We can also see the changes that are going on. I did visualizations of this in the early 90s from 1980s data, and you can see since 2000 a dramatic reduction down to about 10% of the original size of what was the world's fourth largest lake. And on the right-hand side is a typical example which has begun accelerating since the end of 2014 in the breakup of the ice sheet in Antarctica. Probably the most recent example is here showing smoke and soot, which is emitted from the Australian forest fires, which are now recorded as being the most significant fires that have taken place in recorded history in terms of the permeation of that smoke now right up into the upper atmosphere. And on the right-hand side, you can see the darkening of the glaciers, which is caused by the soot inside the smoke itself. But where do we go from here? So we have the ability now, and we have the resources to actually measure where climate change is happening. But we still have a major issue in that no government anywhere is actually funding whether it's a government or a foundation or a private corporation, to make the whole Earth visible to everyone. So we have this idea that every 5 minutes, each one of you could be in space looking down on the Earth from any position at all, day or night, aurora, lightning, nighttime lights or dayside. But we want to make this as open as possible, an open source platform for displaying the whole Earth from any viewpoint. Removing all the access restrictions, it's a great thing that SpaceX did with launching Starman, but it's not a great thing in terms of if that means in the future that space is going to be wholly privately owned. Making the highest resolution depends on what other data is more accessible, but propelling new ways of sharing this real-time Earth everywhere where the internet reaches. To remind everyone, every day, that we actually only have one home. So, we've done a system study on how we can do this. We're using modern technology called CubeSats or picosatellites, a tiny fraction of the cost that it would take to launch an equivalent thing from one of the space agencies. So this shows an example of the orbits, which are highly elliptical at 63 degrees inclination, looking down on the poles, enabling us to see the aurora and also the nighttime lights, so that we have a way of visualizing and stitching all of these images together at exactly every 5 minutes, and therefore counteracting any attempts to pretend that we only have one home. Thank you.